In this video, I'll discuss the answers of 2016 paper. First question, the SI unit used to measure the activity of radioactive source. That is becquerel, that you have to remember. Answer is 1. Question number 2, they are asking for a measurement of a length given that the error due to the measuring instrument is 1 millimeter. And also the percentage error of that measurement has to be kept below 1%. We take the measurement of the length as x, then we can write the percentage uncertainty delta x over x multiplied by 100. Delta x is the uncertainty in the measuring instrument, so that is 1 millimeter. So you can substitute that value 1 millimeter divided by x multiplied by 100, and that must be less than 1%. By simplifying that, you get x is greater than 10 centimeter. So answer is 3. Question number 3. A certain liquid in glass thermometer. That thermometer has been calibrated using the boiling point of water and the melting point of ice. And the bow radius is also uniform. And they have been given some properties of this thermodynamic liquid, and they are asking for the most essential property that this liquid should possess. When you look at the answers, you can understand that all these 5 properties given in the 5 answers are essential for a good thermometric liquid. But here they are asking out of 5 the most essential property that a thermometric liquid must possess based on the facts they have given. They say that this bow is uniform and the fixed point are 0 degree Celsius and the 100 degree Celsius. So this is calibrated by dividing that height into 100 equal parts, and they expect that when the temperature rises, this thermometric liquid also should rises inside the thermometer in a linear way uniformly. So to satisfy that, it should have a uniform volume expansion. The answer is 2. Question number 4, which is not true regarding electromagnetic waves. First one, directions of electromagnetic fields are perpendicular to each other. That is true always. First one is true. Second one, speed does not depend on the medium of propagation, but the speed of the wave changes when it travels from one medium to the other. So, by the knowledge of refraction, you can understand that speed depends on the medium. So, the answer 2 is wrong. So, it is not necessary to discuss the other answers. The answer for the fourth question is 2. Question number 5. A student has suggested some methods to increase the voltage sensitivity of a potentiometer wire. Now think of a potentiometer. Potentiometer has a potentiometer wire, and that wire is connected across a battery. So there is a potential drop across the potentiometer wire. The sensitivity of the potentiometer wire depends on the potential drop per unit length of the wire. To increase the sensitivity, we have to decrease the potential drop per unit length of the wire. Potential drop per unit length is potential difference across the wire divided by the length of the wire. Now look at the answer A. A statement, increasing the length of the wire. When the length increases, then potential drop per unit length decreases, then sensitivity increases. A is right. Then B, connecting a resistor in series with the wire. When a resistor is connected in series with the wire, there will be a potential drop across the resistor. So the potential difference across the potentiometer wire uh, drops, decreases. And then potential difference per unit length also decreases. So sensitivity increases. B is right. Then answer C, increasing the voltage applied across the wire. When the voltage increases, potential drop per unit length increases, so sensitivity decreases. C is not right. Answer 2. Question number 6. This is about a transformer. This transformer has 360 turns in the primary coil and 30 turns in the secondary coil. When looking at the number of turns, you can understand that this is a step down transformer. So the input voltage is higher than the output voltage. And also, transformers deal with alternating currents and alternating voltage. So in that basis, you can choose 2 and 4, and it's a step down transformer. Then you can choose the answer 4. And also you can check the ratio of input voltage to output voltage, and input turns in the primary coil to the turns in the secondary coil. So you get the same ratio. So the answer is 4. Question number 7. A circuit diagram is given. An ammeter and a voltmeter is connected in the circuit. They are asking for the best sets of values for the ammeter resistance and the voltmeter resistance. Ammeter resistance must be very small, and voltmeter resistance has to be very large. So when you compare the answers given, you get 1 ohm resistor as the lowest for the ammeter and 5 kilo ohm resistor for the voltmeter. So answer is 1. Question number 8. Which of the following is not a result of surface tension? Not a result of surface tension. First one, formation of spherical water droplets. Yes, it is a result of surface tension. Capillary rise in water. The rise in water in capillary tubes, that is a result of surface tension. Ability of insects to walk on water surfaces without sinking. Yes, it is a result of surface tension. The excess pressure inside a soap bubble. Yes. 5. Escaping of water molecules from water surfaces. So that is explained by the kinetic theory. Particles with more kinetic energy escape from the water surface. So it is not a result of surface tension. So answer is 5. Question number 9. They have given 3 statements about a standing wave on a stretched string. We'll take the first one. A. The energy does not propagate along the string. Yes, for a standing wave, the energy does not propagate along the string. B. The position of node does not vary with time. Yes, position of nodes are always at the same place. They do not vary with the time. C. Maximum displacement achieved by each particle in the string depends on its position along the string. That is also true. When you take a node, the particles at the node are having a zero displacement. Then particles at the antinode have their maximum displacement. The particles in between node and antinode have their maximum displacements respective to their place, their position along the string. So C is also right. A, B, C, all 3 statements are right. Answer 5. Question number 10. Which gate or gates operate according to the truth table given? Look at the truth table. It has A and F. F is the output, A input. When A is 0, output is 1. When input A is 1, output is 0. So it is equivalent to a NOT gate. So when you look at the gates given, P is a NOT gate. So P tallies with the truth table. So P is one of the answers. Let's see Q. It has 2 inputs and 1 output. We'll write a truth table to the Q gate. So it has 2 inputs, A and B. and output is F. When A is 0 and B is 1, that is plus 5, we can take 1, then output is 0. For an AND gate, output is 0. Then A1, B1, then output is 1. So it doesn't tally with the given truth table. So BQ is not equivalent to this truth table. So Q is not an answer. Then R. R is a exclusive OR gate. For an exclusive OR gate, when the A and B inputs are different, then output is similar to the OR gate. When A and B inputs are 1, then it gets 0 at the output. Let's look at we'll draw a truth table to the exclusive OR gate. A, it also has A, B and F. When A is 0, B 1, then F is 1 as to a OR gate. Then A1, B1, F is 0, so it satisfies that when the A and B are 1, output is 0, which is equivalent to a exclusive OR gate. So R gives similar to the truth table given in the diagram. So R is right. P and R are right. The answer is 4. Question number 11. There are 3 transistors here, and they are asking for the correctly marked polarities to operate the transistors properly. When you look at the transistor A, the arrow indicates from P to N. So A transistor is a NPN transistor. To operate NPN transistor, base emitter junction must always be forward bias. So in A, base emitter junction is forward bias. So A is right. Then B. B, when you look at the arrow, it is from P to N. So B transistor is a PNP transistor. For a PNP transistor, polarities must be reversed. B is wrong. C. C is a N-channel G-FET transistor. To operate this transistor, gate and the source always be reverse biased. But here it is forward bias. So C is wrong. The answer is 1. Only A. Question number 12. Body temperature of a person is given and the peak wavelength of the radiation emitted from the body at that temperature is given. Now the body temperature increases. So they are asking for the new peak wavelength of the radiation emitted from the body. And also they ask us to assume that the black body radiation conditions to be applied. So this question is based on Wien's displacement law. According to the Wien's displacement law, we know the equation lambda mt equal constant. Lambda m is the peak wavelength of the radiation. Lambda m into T is thermodynamic temperature. Lambda m into T is constant. Lambda m, peak wavelength of the radiation. So we can use this lambda mt equal constant to both the instances, and after substituting you get 9.4 into 273 plus 35, that is thermodynamic temperature, equal lambda m into 273 plus 39. Then after simplifying, you get the answer 3. Question number 13. a maximum sound intensity level of a moving jet is given, and sound intensity at the threshold of hearing is also given. They are asking for the maximum intensity of the sound that can be created by the jet plane. We can write the equation for the intensity level. So that is decibel value equal 10 log I over I naught. Decibel value is given 10 log I. I is the maximum intensity of the sound, and I naught is the sound intensity at the threshold of hearing, that is 10 to the power minus 12. So you can substitute the values. 150 equal 10 log I divided by 10 to the power minus 12, and then the next line you can write by dividing it by 10. 15 equal log I divided by 10 to the power minus 12. So then next line you can write 15 equal log I minus log 10 to the power minus 12. Then 15 equal log I plus 12. Minus and minus 12 become plus. 15 equal log I plus 12. Then log I equals 3. I equal 10 to the power 3, which is equal to 1000. The answer is 5. Question number 14. A bunch of water hyacinth is floating on water in a still lake. The wind is blowing over the surface of this still lake, and it was observed that this bunch is moving in the direction of the wind and its velocity is v. And they have given three statements about v. A. Magnitude of v depends on the rate at which the momentum is transferred from air molecules to the bunch. Now to start the motion of this bunch, there should be a force on this. That force is given by the rate of change of momentum. So here when the rate of change of momentum is more, that is force is more, then V is more. Then A is right. B. Magnitude of V depends on the viscosity of water. Now when it is floating, when it is moving, there will be a viscous force in opposite to the direction of the motion. So with this viscous force, this bunch will will move with a decreasing velocity, that is with the deceleration. So velocity decreases. So B is right. V depends on the viscosity of water. C. Magnitude of V depends on the mass of the bunch. When the mass of an object is more, the force required to move a still object is more. So when the mass is more, force is more. So force is proportional to the rate of change of momentum. Then if force is more, V is more. So C is right. A, B, C all are right. Answer is 5. Question number 15. An object falling down vertically in air suddenly explodes into 4 pieces, and which diagram shows the possible direction of motion of the pieces immediately after the explosion. Now it was falling down, and the momentum it had was downwards. And with the conservation of momentum, the total momentum after the explosion also should be downwards. So here in these answers you can see the particles have motion in different angles, Now, if you take all the components of these velocities in x and y directions, you can see that the total momentum can be found downward only in the fifth answer. So, answer 5. Question number 16. Two straight lines shown in the displacement time graph that represents two objects' motions. Uh, Two objects are A and B, and they start from rest at time t equals 0. And they are asking for the true statement about the motions of these objects. First one, the object A has traveled for a longer time than B. A and B both started when time is 0, and they have traveled for a time t naught. Their traveling time is t naught. So 1 is wrong. 2, when t equal t naught, object B has made a displacement greater than A. A's displacement is greater. It is clearly shown in the graph that A's displacement is greater than B. 3. Object A has a greater velocity than B. Velocity of the object can be found by the gradient of the displacement time graph. Now it is very clear that A's gradient is greater than B's gradient. So A's velocity is greater than B's velocity. Answer 3 is right. So the answer for the 16 is 3. Question number 17. An elevator carries a load. It is moving vertically upwards in a building with a constant velocity from second floor to the 12th floor in 20 seconds. The height of each floor is 4 meter. If only 80% of the power generated by the motor is consumed to lift the elevator, and lift the elevator and the load against gravity while moving at constant velocity, they are asking for the power of the motor. Now, the weight of the elevator is 5,000 and the load is 5,000. Total weight downwards is 10,000 Newton, and it moved from second floor to the 12th floor. That is, it moved 10 floors up, and each floor is 4 meter height, and the height this traveled is 10 into 4, which is equal to 40 meters. Then it is moving at a constant velocity, no acceleration. So this 10,000 Newton upward force must be given by the motor to lift this up. So we can find the work done against the gravity when it is moving upwards by the equation Fx. So F is 10,000, x is 40. So we can find the work done. Then the power of this work done is work done over time. So this work done divided by 20, time is 20, we get 20,000 watt. And it says this 20,000 watt is equal to the 80% of the power of the motor. So only 80% of the power of the motor is consumed to elevate this system. So we can write 80% is equivalent to 20,000 watt. Then for 100%, how many watts? So 20,000 divided by 80 multiplied by 100. It is 25 kilowatt. The answer is 2. Question number 18. Three monochromatic light beams, A, B, and C. They have the same intensities. However, the wavelength associated with beam A is longer than that of B. So we can write lambda A is greater than lambda B. and the frequency associated with beam C is smaller than that of A. That is, FC is smaller than FA. With the first relationship, lambda A is greater than lambda B, we can write FA is smaller than FB. When you compare, you can write this relationship. FB is greater than FA, FA is greater than FC. And when you write the equation for a energy of a photon is equal to hf, when the frequency is high, the energy of a photon is high. When the frequency is less, energy of a photon is less. So when you compare this relationship with the equation, you can find the order, ascending order is BAC, which is 2. Question number 19. Two rods of aluminium and copper, their respective fractional increase in original lengths are LAL and LCU. If the temperature is increased, they are asking for the best graph which represents the variation of fractional increase with the temperature. The fractional increase is given by delta L over L. Uh, if if L is the original length and delta L is expansion in length. So fractional increase is delta L over L. Delta L, that is expansion in length, can be written as L alpha theta. So fractional increase is L alpha theta over L, and which is, it is equal to alpha theta. So fractional increase is equal to alpha theta. When you look at the graphs given, you can see in y-axis the fractional increase and in x-axis theta. So when you compare the x and y axis in your in the graphs given, you can see the gradient is given. Gradient of the graph is equivalent to the to alpha, that is expansivity of the metal. So when you look at the linear expansivities of the two metals, you can understand that linear expansivity, that is alpha for aluminium, is greater than that of copper. So gradient for aluminium must be greater than the gradient of copper. Gradient for copper. So, and also when the temperature is 0, linear expansivity is 0. So, with those conditions, the answer should be 1. 19, answer 1. Question number 20. At night, the temperature of a certain room with closed windows in a house made of bricks was observed to be 35 degrees Celsius. Then a person opened the windows of the room for a few minutes at night and allowed the room to be filled with cool air. Then he noticed that the temperature dropped down to 27 degrees Celsius. Then he closed the windows again and observed the temperature, and he noticed that temperature had returned back almost to 35 degrees Celsius in a quick time. And they are asking out of the given answers, which one is most unlikely to be accepted to explain this happening. You know, during the daytime, both the bricks and the air get heated up. During the night time, both will cool down. But the cooling rate of the bricks is lower than the cooling rate of air. Uh, Now, when you think of the temperature of the bricks at night, it is higher and it will have the same temperature as it had in the daytime. It is almost 35 degrees Celsius. And now inside the room, the air molecules have 27 degrees Celsius temperature, and this air molecules will absorb heat from the bricks. Now we go for the answers. First one, rapid movement of air molecules inside the room. Now the air molecules will absorb heat from the bricks and they move faster. They start moving faster inside the room, rising the temperature inside the room. So first answer is acceptable. Second one, collision of air molecules with the walls. Air molecules collide with the walls and absorb heat, and it affects the rise in temperature inside the room. Low specific heat capacity of air. Specific heat capacity of air is low, that is right. With a little heat, it will rise its temperature. So third answer also be acceptable. Fourth one, low thermal conductivity of air. Thermal conductivity of air is low, that is true for air, but the thermal conduction will not happen in air. So there will be no rise in temperature due to thermal conduction. So fourth answer is not acceptable. Fifth answer, high specific heat capacity of brick walls. The specific heat capacity of bricks is high, that is true. Due to that reason, it holds more energy, um, even in even at night. So answer is 4. Question number 21. A small metal sphere is trapped inside a cube of ice of mass 1 kilogram at 0 degrees Celsius. And it was found that this ice cube requires only 300 kilojoule of heat energy to completely melt and form water at 0 degrees Celsius. Specific latent heat of fusion of ice is 330 kilojoule per kilogram. They are asking for the approximate value of the mass of the metal sphere in grams. This 1 kilogram cube is not a complete ice cube. It has a metal sphere inside it. If it was a complete ice cube, it would require 330 kilojoule to melt it. But here it says that it requires only 300 kilojoule. So that there is a balance of 30 kilojoule. If it was a complete ice cube, it would absorb that 30 kilojoule of heat also. And now we can calculate for 1 kilogram ice, it needs 330 kilojoule, and we want to find how much of mass for 30 kilojoule. So 1 divided by 330 multiplied by 30, you get 91 gram. Answer is 3. Question number 22. An ideal gas is taken from state A to state B through two paths, and that is shown in the PV diagram. Energy changes took place in both paths have been given, and they are asking for the amount of heat absorbed by the gas during the path ADB. Remember the first law of thermodynamics, that is delta Q equal delta U plus delta W. Delta Q is heat absorbed by the ideal gas. Delta U is the increase in internal energy. Delta W is work done by the gas. Now we consider the ACB part. There delta Q is 100 joule and delta W is 50 joule. By substituting the values in delta Q equal delta U plus delta W, you get delta U is 50 joule. Now consider the path ADB. There delta W is 10 joule. You have to find the delta Q. And delta U, the increase in internal energy, does not depend on the path it takes. So delta U is the same as before. it is 50 joule. So use delta Q equal delta U plus delta W. Delta U is 50, delta W is 10. Then delta Q is 10 joule. Answer is 4. Question number 23. If the ratio mass of the planet to the radius of the planet for planet A is 4 times that of planet B, then they are asking for the ratio of the escape velocity at the surface of a planet A to the escape velocity at the surface of planet B. Now, what is escape velocity? Escape velocity is the minimum velocity required by an object to escape from the gravitational field. Now, suppose at the surface of the planet, the escape velocity is v. Then we can write the kinetic energy of that object is half mv squared. M is the mass of the object. When it moved out of the gravitational field, its kinetic energy becomes zero. So the change in kinetic energy is half mv squared. So that must be equal to the change in gravitational potential energy. Gravitational potential energy is given by capital G, capital M, simple m over r. Capital G is the gravitational constant, capital M, mass of the planet, simple m, mass of the object, and simple r is the radius of the planet. So half mv squared equal capital G, capital M, simple m over r. Then by that we can get v squared equal 2g capital M over r. 2 and g are constants, and here we are using this relationship to both A and B planets. So we can write v squared is proportional to capital M over r. Then v is proportional to square root of m over r. And we think the escape velocity at A is VA and that of B is VB. Then we can write VA is proportional to MA over RA, VB is proportional to MB over RB, and we write the ratio VA over VB by dividing the two equations. We get VA over VB equal 4 times of MB over RB divided by MB over RB, since they have given MA over RA is 4 times of MB over RB. So by solving this, you get VA over VB equal square root of 4, that is equal to 2. The answer is 2. Question number 24. A network of 5 identical parallel plate capacitors are shown in the diagram. They are asking for the net electric flux through the enclosed surface S. Electric flux is given by Q over epsilon naught. And you have to find the Q, the total charge inside the surface S. When you look at the diagram, you can see that there is a capacitor in the middle. When you consider the voltages at the ends of the that middle capacitor is equal. So no charge will be stored in the middle capacitor. Charges will be stored in other 4 capacitors, and those 4 capacitors are equal, identical, and the charge in each capacitor can be considered as Q. So every capacitor has 2 plates. In one plate it is plus Q and the other plate minus Q. So each of the capacitors has plus Q and minus Q. When you look at this space, you can see minus Q and plus Q. So the total charge is 0. So Q over epsilon naught is 0. Then the answer is 0. Answer is 5. Question number 25. Two cells are connected in parallel. Each cell has an internal resistance of 0.5. They are asking for the power dissipation by the cell combination. We mark the current through the circuit as capital I and then use Kirchhoff's second law clockwise. Then we can write 0.5 into I plus 0.5 into I equal 3.2 minus 3. Then you can find I. I is 0.2 amperes. To find the power dissipation, you can use I squared R equation. I is 0.2 and R, total R is 0.5 plus 0.5, 1. So, by using I squared R, you get the answer 4. ස්තුතියි මගේ channel එකේ අනිත් videos උත් ලබා ගැනීම සඳහා මේ channel එක subscribe කරන්න.